All right, so yesterday we talked about wavelength, frequency, and energy, and we were able to calculate. If you remember, this is the wavelength, okay, and it's always in meters. We've got V, which is your frequency, which is in hertz, and we've got energy, which is always in joules per second. Now, things that were constant yesterday, we know that the speed of light is always 3 times 10 to the 8th meters per second. Okay, we know that Planck's constant is 6.626 times 10 to the negative 34. Okay, so why are we learning all this? Well, I said that we were going to be talking about electrons and how they move. Well, electrons have specific quantities of energies as they go through and come down energy levels. So if I look here and I create a wave, so this is sometime, let's just say this is from 0 to 1 minute. So if I look from, this is the crest of the wave, this is the trough of the wave, and from here to here is the wavelength. And if I want to look from here to here is the amplitude. Now, what you're looking at when you're doing this is we can determine if something has a very long wavelength. So long wavelength equals low frequency and low energy. Okay? Short wavelength. The shorter the wavelength means that it's going to have a high frequency and a high energy. So that's why I said yesterday how gamma rays are most penetrating, because their frequency, if you look at gamma rays, it's very high frequency. Okay, so how does all of this relate to the electrons? Well, if you remember from the planetary model, Bohr said that you have your nucleus and then you have these little energy levels. Okay, well, going up and down in energy levels creates, sorry, my circles are not completely like they need to be. All right, so if I look, this is n equals 1, meaning the first energy level. This is n equals 2, meaning the second. N equals 3, n equals 4, n equals 5, and n equals 6. So here's what you need to be able to see. If an electron moves up an energy level, it has to absorb energy. Okay? When an electron falls down an energy level, then it releases energy and it gives off light. Okay? So here's what I want you to see. There are 3 variations of light that we're going to look at. Okay? If I start, no matter where I started, let's say I'm at 6 and I drop all the way down to 1. So this is where my electron is. I drop all the way down to 1. Anytime I go from an energy level down to level 1, it's going to give off UV light, always. So it doesn't matter if I'm at 5 and go to 1 or if I'm at 3 and go to 1. I'm going to give off UV light. Okay? Now, I'm going to tell you another kind. Let's say that I'm looking at dropping to energy level 2. So at energy level 2, this is where visible light is. Anytime we fall to the energy level 2, okay, you're going to give off visible light and you're going to give off a specific color. So we're going to look at 5, 6, 4. All right, sorry, messed that up. Let me rewrite my numbers. So we're going to look at 6, 5, 4, and 3. All right, so if I'm at level 6 and I go, so I'm here, and I stop at level 2. Oops, level 2. Got to go there. That's going to give me purple. Okay, I'm going to see purple if my electron's at level 6 and falls to level 2. Okay, if I'm at level 5 and I fall to level 2, I'm going to get blue. All right, if I'm at 4 and I fall to level 2, I'm going to get green light. And if I am 3 and I fall to level 2, I'm going to get red. Now, remember how yesterday I talked about which has the most energy versus the least energy? And you said that red had the least amount of energy. It has a longer wavelength. So a transition of electrons from level 3 to 2, this is low energy. A transition from level 6 to 2 is going to be a higher energy, okay? So the third type of electron falling and the type of light that we're going to look at is what's called infrared light. So I'm going to use, all right, so anytime I'm at level 3 and I go, I'm sorry, not level 3, I'm dropping to level 3, sorry. Let me scratch that off. Let me draw back in level 3. All right, so if I am at level 5 and I drop to level 3, I'm going to give off infrared. Okay? If I'm at 4 and I drop off to level 3, I'm going to give off infrared. So here's what you've got to remember. All right? Oops, I think I have my page. All right. So no matter what, if I'm going to just put a high energy level and I'm dropping all the way down to 1, I'm going to give off UV light. If I'm at a higher energy level and I'm dropping to level 2, if I'm from 6 and going to 5 to 2, then I'm going to give off violet. If I'm 5 and going to 2, I'm going to give off blue. If I'm 4 and going to 2, I'm going to give off green. And if I'm 3 and going to 2, I'm going to give off red. And then the last type of light, so notice we've got UV and visible light. The last time is I'm at some higher energy level. If I drop to 3, I'm going to give off infrared. So in terms of energy, this has the highest energy. Then it would be this is the next, and this has the lowest. So let's look at some of these questions. So this is the typical Bohr model. Okay, see how I did N1, N2, and 3? That's what I was showing you earlier. All right, if we look at this graph, here's your electromagnetic spectrum. See how gamma rays is over here where it's higher energy? Okay, shorter the wavelength, higher the energy. All right, it says when an electron transitions from N1 to N3, is energy absorbed or released? Well, remember, if I go up, energy is always absorbed. Okay? Now, it says what color of light is given off when an electron transitions from N4 to N2. So I'm going to go back up here. If I'm at N4, all right, I'm here, and I'm dropping to 2. You got to remember what I said. If we fall to 2, we're going to give off some form of visible light. And 4 to 2, and this is just a memorization thing, 4 to 2, you're always going to give off the color of green. Okay? All right. Let's look at the next few questions. It says, what does a longer wavelength suggest about the energy of the emission? Longer wavelength, less energy, right? Okay. So give an example of an electron that absorbs energy. The only way it can absorb is if you go from like N1